Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. The third reaction is the redox reaction. Okay, so redox reaction is actually a reaction that will involve both reduction and also oxidation happen simultaneously. Let's go through what is the oxidation and reduction. Oxidation is a reaction when a substance lost one or more electron. When the electron lost by any substance means that substance undergo oxidation reaction. Okay, when the substance lost the electron, the oxidation number of that substance will increase, and at the same time it will act as a reducing agent, or what we call as a reductant. As for this reduction reaction, okay, it is happen when a substance gain one or more electron. Okay, when the electron received by any substance, we said that substance undergo reduction reaction. And what happened is the oxidation number of that substance will decrease. And at the same time, okay, the substance that is reduced or undergo reduction will known as the oxidizing agent or oxidant. Look at to this terminology. Okay, there are two substances here, there are two particles here. We have a X and also Y. Okay, so look at to the electron that is being transferred from X to Y. So what happened to X? It is actually lost its electron. Okay, when X lost its electron, we said that X undergo oxidation, so it is oxidized. Okay, when X is oxidized, X will act as the reducing agent, and the oxidation number of X will be higher than before. For the case of Y, since that Y receive electron from X, okay, so that Y gains electron means Y undergo reduction, so it is reduced. Okay, when Y is reduced, Y also an oxidizing agent. The oxidation number of Y will decrease. So in the redox reaction, we have to be able to determine the oxidation number of any atoms. Okay, there are several rules that will apply. Okay, let's go through one by one. Okay, in determination of the oxidation number. So let's look at to the first rules. We have a free element. As n atoms or molecule, the oxidation number of them is 0. Okay, free element. Example given here is if we have a sodium exists as Na atom, the oxidation number of this sodium is 0. Bromine exists as Br2. Okay, even though this is a molecule of bromine, but it is free element, there is no other elements attached to it, then the oxidation number of this bromine is also 0. Okay, oxidation number of magnesium 0. Oxidation number of the oxygen in O2 0 as well. Second rules, for the monoatomic ion, the oxidation number will be the same as the charge of that ion. Okay, look at to the first example that is given. We have the sodium plus ion, so that the oxidation number of this sodium, okay, when it is exists as this monoatom ion is plus 1. Okay, it follow its charge. Aluminium 3 plus. So the oxidation number of this aluminium when it is exists as this ion will be plus 3. If we have sulfide as 2 minus, so the oxidation number of this sulfur is negative 2. The third rules, if we have a fluorine or other halogen, their oxidation number will always negative 1 if they are in the compound. Okay, if the fluorine and halogen exist in a compound, okay, and the oxidation number is negative 1. Okay, however, the halogen will have a positive number when they combine with oxygen. Okay, example, if we have a sodium fluoride NaF, oxidation number of fluorine is negative 1. Oxidation number of this chlorine okay, when it is combined with the H in HCl molecule is -1 as well. This is the general rules for the halogen. They are always -1. Okay, however, when we have a chlorine, okay, form a compound with the oxygen in the Cl2O7, okay, this is when we start to have the exception. The chlorine will have a positive oxidation number. This is because oxygen is always -2. Okay, so how do we get this +7? Okay, since that in the Cl2O7, okay, we have 2 chlorine and also 7 oxygen, and this is a neutral molecule, so it is equal to 0. Okay, and then 2 chlorine plus 7 oxygen that always have oxidation number of -2 equal to 0, so that chlorine is equal to 14/2 is equal to +7. Okay, other than this assumption, then the halogen will have a -1 oxidation number. The fourth rule is on hydrogen. Okay, the hydrogen will always have oxidation number of +1 except if this hydrogen in metal hydride, when the hydrogen attached to a metal, okay, in which the hydrogen will have oxidation number of -1. Okay, so this is the normal condition when we have a hydrogen combined with the chlorine in the HCl. The oxidation number of this hydrogen is +1. However, if we have a sodium hydride, okay, sodium metal attached to the hydrogen, okay, we start to have assumption, okay, and the oxidation number of this hydrogen is now -1. Same goes when we have magnesium hydride, MgH2. Okay, so the oxidation number of this H is -1. The fourth rule is on oxygen. Okay, oxygen have an oxidation number of -2 in most of its compound. Example, when oxygen combined with the magnesium, MgO, oxidation number of this oxygen is -2. Another example, if you have a molecule of H2O, the oxidation number of this oxygen is also -2. However, there are two exceptional cases for the oxidation number of oxygen. Okay, the oxidation number of oxygen is not -2 anymore if it is in peroxide or if that oxygen combined with fluorine. Okay, example that is given, if we have a peroxide in the H2O2, hydrogen peroxide, okay, the formula is HOOH. So this time the oxidation number of this oxygen become -1. Okay, why the oxidation number of oxygen become -1 in the hydrogen peroxide or in peroxide compound? Because the oxidation number of the hydrogen, okay, from the previous rule is +1. Okay, so from the calculation, we'll get the oxidation number of oxygen it is in the peroxide is -1. And then the second exception for the oxygen just now is when it is combined with the fluorine, since that fluorine is always -1. Okay, so that it will make oxygen's oxidation number become +2. So example is given in OF2. Okay, so if we try to calculate the oxidation number of oxygen, since that we have 1 oxygen in the molecule, 2 fluorine in the molecule, and it is neutral molecule, so equal to 0. And we know that fluorine is always -1. To multiply -1 equal to 0. So oxidation number will be +2. And then rules number 6, if we have a neutral molecule, the sum of the oxidation number of all atoms in that molecule will be equal to 0. Okay, for example, if we have a H2O molecules, after we add or after we got the sum of the oxidation number of these two hydrogen atom and also one oxygen atom, okay, they are supposed to be equal to 0. Okay, if we have a HCl, so that the oxidation number of H plus oxidation number of chlorine will be equal to 0. If you have a potassium permanganate, the oxidation number of the K potassium plus with the oxidation number of manganese plus oxidation number of 4 oxygen, and it is supposed to be equal to 0. It is because they are all neutral molecule. However, if we have a polyatomic ions, the total oxidation number of all atoms that made up that polyatomic ion must be equal to the net charge of the ion. For example, if we have a KMnO4 minus, so the oxidation number of K plus with the Mn plus with the 4 oxygen is supposed to be equal to its charge, which is -1. Okay, another example, if we have Cr2O72 minus here, okay, so this -2 is actually the total or the net charge of the whole ion. Okay, -2 is belongs to the whole. It is not belongs to the last atom. Okay, so that the oxidation number of 2 chromium and also 7 oxygen that is in this polyatomic ion will be equal to its net charge, which is -2. Okay, so from this, we can determine what is the oxidation number of chromium, since that we have discussed the rules on oxygen. Okay, so 2 chromium plus with 7 oxygen with a -2 oxidation number each equal to -2, so that chromium will be equal to plus 12 over 2, it is equal to plus 6. Okay, this is for the chromium. Another example that is given here, when we have a nitrate and O3 minus, so the -1 is the charge of the whole polyatomic ion. Okay, so the oxidation number of nitrogen plus with the oxidation number of 3 oxygen, they are equal to -1, which is the charge of the nitrate ion. So this is the exercise. So please answer this question.